Is 1668. It says knowing the angular velocity of link B AB, which is 4 radian per second, and we have to determine the velocity at collar C and the angular velocity of link CB. And for this particular question, the link CB is horizontal at this instant, and the diagram, it shows the length of CB, which is 350 millimeter, and AB, which is 500 millimeter, and it also tells us that the angular velocity at AB link is anti-clockwise, and the rod on which the collar C is connected has an angle of 45 degrees with the horizontal, and the link AB has an angle of 60 degrees with the horizontal. So first we draw the diagram in which we add some other information. So first of all, we have to add that where the velocity C and B will be acting, because to get velocity C we have to know velocity B. So as you can see that velocities will always be perpendicular to the link. So as you can see that velocity B is perpendicular to the link AB. So to find the angle between CB link and the velocity B link, so we have to know the angle between the link CB and AB, which we get 60 degrees, because the 60 degree given over here is equal to this one due to alternate angles geometry, and we subtract 60 from 90, so we get 30 degrees over here, and velocity C is perpendicular to the link over here, and it has degrees of 45 with the horizontal, and we get the same angle because of the alternate angle property from here. So starting, we have to, the given thing is that we have 4 radian per second of angular velocity at AB, so we can use this to find the velocity at B, which is 2 meter per second, as we convert the millimeters into meters, so that's why we divide 500 by 1000 and we get 2 meter per second. And then we divide the velocity at B into its I and j components. So we use the right angle triangle property, as we know that the velocity B will be the hypotenuse and it has a 30 degree angle, so we use that property to get a x component and y component, which are like I and j in this case. So we further simplify them and we get the equation in form of minus 1.732 I plus j. So as we know that to find the velocity at C, so VC is still unknown, but we know that it has an angle of 45 degree with the horizontal, so we use that property to get the velocity of C in its I and j components. We are doing this component dividing into components because later in the question we can use that in the comparison method. So we do the same as we did with VB, but in this case velocity C as written as it is because we don't know its value. And then we use the equation VC is equal to VB plus angular velocity at BC multiplied by the length, which is C relative to B, because like the direction we have given is from B to C. So we simply have two equations in form of velocity C. One is in form of velocity c in its I and j components, and one is in form of the angular velocities and the velocity b, and then we put them equal to each other, and then we just compare the I and j components. By this we get velocity c, which is 2.45 meter per second, and we know its direction from the diagram, that it is acting towards vertically downwards and with a slight angle as well, so angle of 45 degrees. And we use the velocity c value we find over here, and in j using the j component comparison we are able to find omega bc, the angular velocity at bc, and we get the value 7.81 radian per second. As the value is positive, we know that it is acting in anti-clockwise direction.